Hi, this is Professor Earth, and I'm a climate scientist at the University of Alaska. I've got a riddle for you. What kind of dog do scientists like? Well, they like labs, of course. The winters have gotten milder in Alaska due to global warming, but this winter we had an old-style winter. We had temperatures of minus 45. Then we had temperatures of minus 48, minus 50. It was really tough for about 3 weeks. Alaskans have developed a secret way of dealing with the long, dark, cold winters, and that is take a break and travel to somewhere warm and sunny. So I was lucky because I was investigating a new story about sponges and a paleoclimate record that vastly improves our understanding of global warming. Once I got to the Virgin Islands, I started to look for these sponges. I used my scientific wisdom to seek out various kinds of sponges, and it wasn't these. And it really wasn't this one. No. These sponges grow at between 90 and 150 meters in the sea, so they're down about 100 to 300 feet. And they're a particular kind of sponge. They're not the soft sponges that they use to make loofahs. They're little hard round balls called sclerosponges. And the hard shells are made of calcium carbonate, and they record variations in ocean chemistry that reflect paleotemperatures. Malcolm McCullough and his co-workers published this very important scientific paper about the sclerosponges in nature climate change. And what they showed by looking at the chemistry of the sponge is that there's a very strong correlation between the strontium-calcium ratio and paleotemperatures. They compare it against known temperatures through a reference period, and they get a very highly correlated result showing that it's very good at calculating what ocean temperatures are. The correlation coefficient, or the R-squared, is about 0.91, so it's a superb correlation. And what this means is they can take their 300-year-old sponge and go back in time by measuring these ratios through older and older parts of the sponge and create their own paleoclimatic record. And this plot shows this paleoclimatic record. The little gray squares are the CO2 record, showing it increasing in the atmosphere. And the yellow, the various colored dots, the blue, are the sponge data. And what they show is after a little cooling period in the early 19th century, beginning about 1850, there's a very progressive warming that matches the increase in CO2. This proves that global warming started about 1850 in response to the CO2 production entering the atmosphere. So the sponge paleoclimatic record looks great. And interestingly, it does not completely agree with the thermometer record of climate change at those times. Now, the thermometer record is arbitrarily cut off in 1850 because people say, oh, it's not good before that. But it's also not very good in the late 19th century because there weren't many thermometers and there aren't many measurements and they weren't in the right places. So the sclerosponge paleoclimate record suggests there's more global warming has occurred than the temperature record from thermometers suggested. And we can also use this record to project into the future because we know that CO2 is going to increase and we know how much warming has occurred according to the sponge record. And when we do that, we see that we've already gone through the 1.5 degrees C barrier for warming that was set in the Paris Climate Accords. In fact, we went through that several years ago. And at the current time, we're not at 1.5. They think we're at 1.7 or even 1.8 because 2023 was so warm. And going forward, this data suggests that we'll blow through the 2 degree global warming, quote, limit by the end of the 2020s. So we're warming much more rapidly than the IPCC predictions suggest. Well, this is very controversial because many scientists rely almost exclusively on the instrumental record and ignore much of the other data set in terms of paleoclimate. For instance, Professor Michael Mann, a very eminent, a brilliant scientist, has said he's extremely skeptical that we can overrule the instrumental global temperature record. He said the sponge data doesn't even pass the smell test. Well, it's hard to argue with that kind of logic, but I'm going to try here. For instance, let's look at the thermometer record. We know that back in the 19th century, there's very little data. The only data we have for the oceans, for instance, is from a few ships taking measurements, often throwing buckets overboard and then measuring the temperature in the bucket after it's brought up on deck. And if these were steamships, much of the water was probably heated by the ship's engine before it came on board. So there are real problems with this data. There are many more measurements on land, but even here, most of the thermometers are located in cities where there are heat islands or even inside buildings. So the thermometer data, at least in the 19th century, is not terribly good either. So my suggestion is that really we should take all the data. We shouldn't cherry pick and just decide we're only going to look at thermometer data or only look at sponge data. A responsible way to deal with climate change is look at all of the data, evaluate it all, and even combine it, if necessary, to understand completely what's going on with the climate. Another way to evaluate things is to look at the carbon record. That's what's causing the warming. Does it make sense that we'd see global warming earlier, as the sponge record says? Or does it make sense that we don't see global warming until 1900, say? Well, in fact, if we look at carbon budgets, we were putting a heck of a lot of CO2 in the atmosphere well before 1900. We had the English First Industrial Revolution, widespread use of coal in manufacturing, trains, and in fact, if we look at atmospheric CO2 records, we can see increases in global CO2 beginning way back, before 1850. You can see it in the record. Look at that increase in CO2 in the atmosphere picking up about 1850. It makes perfect sense that that's when global warming would begin to be seen on a global basis. So the contrast between the sponge record of climate change and the IPCC record are very large. For instance, the IPCC is saying global warming so far is about 1.2 degrees. Sponges say 1.7, half a degree greater. The sponge record says the world is 2 decades ahead of where the IPCC says we should be now. Furthermore, the sponge record says the world's going to exceed 2 degrees warming by the end of this decade. So that's much more rapidly than the IPCC is saying. That means global warming is much more dangerous than we've been led to believe. And as for me, when I went back to Alaska, that nasty cold snap I described, the severe winter weather, that was over. Suddenly it was warm. We were a month ahead of where we normally are. It's much warmer than we'd expected, and that's very bad for polar bears. But that's another story.